Hey, in this video, I'm going to go through an example of cross-account access, then cover policy evaluation logic between an identity and resource-based policy within the same account, then cross-account. If you haven't watched the first two videos, I recommend checking those out first. I'm going to first start with cross-account access. In this example, we have a demo user who wants to be able to access a resource that's owned by another account. In this case, it's the test table. In order to do this, the demo user is going to assume the role DDB role, which has permissions to call getItem on the table. The trust relationship for this role allows any user in the 409 account to assume the role, and the demo user will have permissions to call STS assume role on the role in order to assume it. Once the user then assumes the role, they can then make getItem calls to the table. I'm going to first show you the test table that I created in the 748 account. In DynamoDB, I created the table, and if I go to explore items and select the table, you can see that there's a key value called ID and an attribute called color, and I put one item in with the key of 1 and the color of red. This is what we're going to use to test getting the item. I'm going to create the DDB role and first start with making the permissions. In IAM, I'll go to policies and then create a policy. I'll search for DynamoDB and we're going to allow, and under read, I'll select getItem. This is the action that we want to be able to perform. For the resource, I'll specify a specific resource by the ARN value. So I need to grab the ARN of the table. Under tables, I can find the ARN and paste it in here. I'll give the policy a name. I'll call it DDB access and then create the policy. If I expand that customer managed policy that we just created, we can see that we allow the getItem action on the table. Now I'll create the role and then attach this policy to it. So under roles, I'll click create role. And then the trusted entity type will be an account. And it will be another AWS account. I'll grab the account ID from this tab and paste it in. Then click next. Now I'll attach policies to the role. So these will be the identity-based policies, and we want to attach the DDB access role policy. Finally, I'll give it a name. I'll call it DDB role. And then we can see the trusted entities. We're allowing STS assume role for this account. And then they'll have these permissions. Create role. And now the role is created. So if I open it up, we can see we have the DDB access permissions. And under trust relationship, we define who can assume this role, and it's any user in this account. Now that I have the DDB role all configured, I need to create a permissions policy for the demo user to be able to assume that role. I'll start by clicking on policies and then create a new policy. I'm going to write the JSON for this policy. For the action, it's going to be set to STS assume role. And then the resource is going to be the role that we want to be able to assume. So I'll copy the ARN value of the role from the other account and paste it in. Next, I'll give it a name. I'll call it cross account and then create the policy. Now I need to attach this cross account policy to the user. So I'll come back to users, click on the demo user, and then add permissions. I'm going to attach a policy directly and then search for the cross account policy. I'll click next and add permissions. Now this user has permissions, which allows them to call STS assume role on the DDB role in the other account. I'm going to try assuming the role in the terminal and then make calls to perform the get item action on the DynamoDB table. First, let's see who I'm signed in as. When I call AWS STS get caller identity, it returns the ARN of the demo user. Now I'm going to assume the DDB role in the other account. Similar to what I did in the previous video, I'm going to call STS assume role, requesting the new role, and then pass those into environment variables in my shell. Now, when I run the same command, get caller identity, it should return the DDB role. To show that I can access the item from the table, I'm going to perform this command, AWS DynamoDB get item, and then I'm going to pass through the table name as test table, and for the key, it's going to be the ID string of 1. And if you want to see how I got this value, if I look in the documentation, I can search for any service. So in this case, DynamoDB. And then under available commands, if I look for get item, the get item command, I can see that I need to provide the table name and the key, and then it provides all sorts of documentation on the formats of everything. So when I run it, I now get that the color for the ID of 1, the color is red, which is what exactly we saw when we were looking at it in the console. If I unset the access key, secret access key, and session token, and then fall back on the credentials that we originally configured, then I want to show you that the command that we ran before, the get item, would be denied. So I'll call get caller identity just to confirm I am back as the demo user. And then if I call get item, we get access denied. Now I'm going to show an example of policy evaluation logic between an identity-based policy and a resource-based policy in the same account. In this example, the identity-based policy allows S3 list actions on any resource, and the bucket policy allows the principal, who's the demo user, the ability to perform put object actions on the bucket. Even though the user doesn't explicitly have the put object action in its identity-based policy, it'll still be able to perform the put object action. And even though the bucket policy doesn't explicitly give the demo user the ability to list objects, it's still going to be able to do so because the identity and the resource are in the same account. First, I'm going to create the identity-based policy for the demo user. In account 409, I'll go to policies and then click create policy. For the action, we'll give S3 list, and the resource will be any resource. I'll click next and then give it a name. I'll call it custom S3, and then I'll create the policy. Once the policy is created, I'll go back to users, open up the demo user, and then I'll add the permissions. I'll attach the policy directly. And then add it. Now the identity-based permissions are created for the user, I need to create the resource-based policy for the bucket. I'll go over to S3 and open up tutorial bucket 1, and then under permissions, I'll edit the bucket policy. I'll add a new statement. For the action, I'll give S3 put object. For the principal, I'll set it to be the user, so AWS, and then I'll copy the ARN of the user. And then for the resource, I'll set it to be the bucket by copying the bucket ARN and then allowing any path within it. I'll save the changes and the bucket policy is set. Now I'm going to perform a list command and a put object command on the bucket from the terminal. I'll first run AWS STS get caller identity to confirm I'm signed in as the demo user. Now I'll list the files in the bucket. The bucket is empty, so I'll perform a put object command with cp, AWS S3 cp. So the file I have locally, note.txt, was uploaded to the bucket. So now if I list the bucket again, I should see the file, and it's now in there. After showing the policy evaluation logic within the same account, I'm going to take this example and split it across two accounts. I'll leave the demo user and its policy the same, but create a new bucket called tutorial bucket 3 and account 748. The principal will still refer back to the demo user, but the resource will be updated to also reflect tutorial bucket 3. I'll then show that even though the demo user has permission to list on buckets, and the tutorial bucket allows the principal, being the demo user, to perform the put object action on the bucket, neither action can be performed because they both don't grant the same actions. Since the demo user and the policy are not changing, I just need to update the bucket policy for tutorial bucket 3 in the 748 account. I already created the bucket, tutorial bucket 3 in the 748 account, so I'll go to permissions and edit the bucket policy. I'll add a new statement, and then I'll just copy the statement from the previous one, replace it, and then just update the name. Now we're allowing the principal, which is the same demo user, the put object action on the bucket. I'll save the changes, and it's updated. I'm now going to try running the two commands to see if either of them work. I'll start with listing. And we get the access denied. If I try the put object, it should fail as well. Since the identity permission didn't grant put object, but the bucket policy did, it fails. I'm going to come back to the demo user and then edit the custom S3 policy to give it permission to put objects. I'll add S3 put object and save the changes to the policy. If I refresh the permissions, we can see we now have list actions and put object actions on any resource. If I try and put the object again, the upload succeeds. If I take a look at the objects in the S3 bucket, we can see the file is now in there. I hope these videos gave you a better understanding of IAM. If you found it helpful, please subscribe. I'll be releasing more videos on AWS, so leave a comment on any topics you want me to cover in the future. Thanks.